All right, I briefly want to discuss a couple of basic volume formulas. Again, I'm guessing you've worked with these probably in middle school. You've probably worked with these again in geometry. This is probably nothing new. But remember, when you're working with volume, you're talking about the number of cubes that could fit inside a shape. Okay, so we talk about cubic units. How many 1 by 1 by 1 cubes could fit into a shape? Remember that a prism is a shape that basically has congruent shapes on the top and the bottom and straight rectangular sides connecting those. So for example, you could have a square prism. Let's see if I can actually draw this. A square prism would have square bases. So maybe the base is a 4 by 4 and let's say the height is 10. Okay, so you're basically, if you were stacking blocks here, you'd fill out the blocks in that 4 by 4 base and you'd stack that same set of blocks over and over again, 10 high. Okay, and what that leads us is the idea that really to find the volume of a prism, and this is regardless of the shape of the base, you really just need to figure out how many cubic blocks could you fit in the base of one of those. You're stacking that same number of blocks on top of each other again and again, which means you really just need the base area, which tells you how many blocks you'd be putting on one face, and then just multiply that by the height. So the volume is equal to the area of the base times the height. Okay, and I'm going to use a capital B to represent the base area. All right, and so in this particular case, base is a 4 by 4. Okay, so 16 blocks could fit into that base. The height is 10, so you could fit a square of 16 blocks and then stack that on top of itself 10 times, and you'd end up with a volume of 160 cubic units. Okay, so you used a U there and cube for those. Okay, that works for any prism. Okay, so you can have a pentagon upper base and a pentagon lower base. Okay, and if you can find the area of those bases, you're still multiplying the area of the base times the height. So let's say that the base area here, let's say that you find the area of this pentagon to be 25 square units. Okay, in other words, you could fit 25 blocks inside that pentagonal base. If the height was 5 units, you'd just be stacking 5 of those 25 square unit pentagons on top of each other. You're still going to take the area of the base and multiply by the height. So like in this example, it'd be 25 times the height, which in this case is going to be 5, be 125 cubic units. Okay, so you can have triangular upper and lower bases, you can have rectangular upper and lower bases, you can have hexagon upper and lower bases, doesn't matter. For these problems, most of the time your work is going to go into finding the area of the base, okay? Because obviously, as you'll see in our other videos, finding the area of a regular polygon does take a little bit of work, okay? A cylinder is really just a circular prism, okay? You've got a circle on top, you've got a circle on the bottom, and so your base area here, let's say the radius is 5, and let's say the height is 8. Okay, same kind of thing. You're figuring out how many cubes you can fit on the base, which would just be the area of the base. Okay, and then you're going to multiply by the height. Okay, so you can actually say that the area of the cylinder is the area of the base times the height. That formula will totally work. Okay, if you've got the same base on top, the same base on the bottom, and straight sides connecting those, that formula always works. Doesn't matter what the shape is. Okay, that being said, the area of a circle is really pi times the radius squared. Okay, so most textbooks are going to say area of base is pi r squared, multiplied by the height. Pi r squared h is going to be the volume of a cylinder. Okay, so in this particular case, pi times the radius of 5 squared times the height of h, 8. Area of the base is going to be 25 pi. 8 times 25 pi is going to be 200 pi. And remember, that's cubic units, okay? So that's a little bit over 600 cubes that could fit into that shape if it had those dimensions. Okay? Remember that when your shape comes to a point, that's either a pyramid or a cone. If your shape comes to a point, you're going to have to multiply by 1/3 to find the volume. So the volume of a pyramid is 1/3 the area of the base times the height. The volume of a cone is going to be 1/3 the area of the base times the height. The area of the base, because it's a cone, will be pi r squared and then the height will be h. So you probably learned that formula as 1/3 pi r squared h. Okay? Again, these are very basic shapes. These are volume formulas that everybody needs to know. Don't assume that they're going to give these to you on, say, the AP exam or the ACT. Okay? Just a real quick example here. So remember that a pyramid has some kind of a base. So if it's a square base, we call it a square pyramid. If it's a triangular base, it'd be a triangular pyramid. Rectangle base would be a rectangular pyramid. A pyramid has one single point above that base where all the sides come together. Okay? So for example, let's say we have a 10 by 10 base, and let's say that the altitude here is 12. You're going to need to superimpose possibly some right triangles into the drawing to find certain dimensions. Now in this particular case, we have the dimensions of the base. The volume is going to be 1/3 the area of the base times the height. The base area is going to be 10 times 10, which is 100. Okay? The height in this case is going to be 12. Okay? 1/3 of 12 is 4. 4 times 100 is 400 cubic units. Okay? So in this particular case, we had enough information to find the volume of this thing. If I wanted to find, for example, the surface area, I would need to find the areas of those triangular faces, plus I would want to add in the base. That's going to take a little bit more work, okay? And this is where the idea of the slant height comes into play. If I wanted to find the area of one of these 4 triangular faces, I would need the height of that triangle, need the altitude, okay? That height in this 3-dimensional diagram is right here. So hopefully you can see you've got a right triangle here, okay? This is going from the center of the base out to the side. That length there is going to be 5, okay? This little 5, 12, 13 right triangle. So the height of one of those faces is 13, okay? We call that the slant height. For some reason, in a lot of diagrams, it's represented with an L, okay? I have no idea why it's an L, but they don't use an S a lot of times. A lot of times it's an L, okay? So to find the area of one of these triangles, you take half the base times the height. You take half of 10 times 13, and I think that'd be 65, okay? If you're going to find the surface area then, the lateral surface area would just be the area of the sides. So you could take 4 of those 65s and you could add those together, and I think that would be 260 square units. If you're trying to find the total surface area, and sometimes they call it the total area, you'd be adding that 260 to the base. The base is a 10 by 10, and you get 360 square units, okay? So remember, when you find a surface area, it's just the area of each of the faces added together. I don't memorize a whole lot of formulas for surface areas, quite frankly, because again, you're just finding areas of rectangles and triangles and different kinds of shapes. And typically, you know, other than maybe having to use right triangles to find some dimensions, you're going to have most of the information you need, okay? For a cone, similar kind of thing. A cone, the volume is 1/3 the area of the base times the height as well. Let's say that this radius is 6, and let's say that that length there is 10, okay? That length of 10 is not the height of this cone, okay? That's the slant height, okay? It's the slanted height, okay? That's your L value there, okay? The altitude would hit the base at a perpendicular, would be right there, okay? And if you notice, this little 6, 8, 10 triangle, sometimes you get lucky and they're triples, sometimes you're going to have to use the Pythagorean theorem or angle measures, that sort of thing. But in this case, we can use the formula 1/3 pi times the radius squared times the height of 8, okay? That's going to be 36. 1/3 of 36 is 12, okay? 12 times 8 is 96 pi cubic units, okay? So that's how you would find the volume of that particular cone, all right? The last example here, I didn't mention it in the video, but I'll put it in here. Finding the surface area of a cone. The lateral area, the area of the sides, the area of the cone part of the cone. The formula for that is pi times the radius times the slant height, okay? Pi r L, okay? So in this particular case, that's going to be pi times the radius of 6 times the slant height of 10. So it is something that needs to be known sometimes, and that's going to end up being 60 pi. Okay, again, if you're finding the total surface area, you're going to have to add the circular base. Okay, so you would take that 60 pi that we got for the sides and you would add the area to the circle base. You've got a radius of 6 here, so the area would be 36 pi, and 96 pi square units would be the surface area of the entire cone. So watch if you're asked to find the area of the sides, lateral area, versus asked to find the total area, which would include adding any bases. Okay, and of course that would also apply to prisms and cylinders. Oh, by the way, I didn't mention surface area of cylinders. Probably a little bit less known formula, but probably not a terrible thing to mention it. If you're trying to find the surface area of a cylinder, imagine you had a can, okay? And imagine that you're going to peel the label off the can, okay? I'm trying to find the areas of the sides of that cylinder, okay? If you peel the label off a can, that's really a rectangle. Rectangle, of course, you can just find the area by taking base times the height. So let's look here. Let's say we had a radius of 6. Let's say the height's 10, okay? That label would go all the way around a can, all right? This length here is just the circumference of the circle. The circumference of the circle is just 2 pi r, okay? So you can take 2 pi r times the height, and that will give you the lateral area of a cylinder. 2 pi r h would be the lateral area. So in this particular case, the height would be 10. The circumference would be 12 pi. Okay, you can take 10 times 12 pi, 120 pi square units would be the area of the sides of that can, all right? If you wanted the total area, which I abbreviated with T and A, you would add the area of that upper circle and the area of that lower circle. So that would be 120 pi. You're adding the upper circle, which would have an area of 36 pi, and you're adding the lower circle, which would have an area of 36 pi. That's going to be 72 pi. Looks like you get a total of 192 pi square units if you're looking for the surface area of that cone. All right. So again, probably things you've seen, probably saw the formulas in middle school at some point, and probably looked at these things more carefully in geometry. Anyway, if you don't know these different relationships, you might want to write those down somewhere so you've got those to look at. Okay. One additional formula that I should mention, things having to do with spheres. A sphere, the surface area of a sphere is 4 pi r squared. Okay, so interesting, you can find the area of basically a circle with the same radius, just multiply by 4, you've got the volume of a sphere. The volume of a sphere is actually linked to the surface area formula, but probably something you won't understand until you get to calculus, is 4/3 pi r cubed. Okay, we're talking about a volume. You're always going to have some three-dimensional aspect, either 3 dimensions involved or cubing involved when you're finding a volume. And so, for example, if I had a sphere, let's see if we can kind of sphere aspect here. Let's say the radius was 4. The surface area would be 4 times pi times 4 squared, which would be 64 pi square units. The total area would be 4/3 times pi times the radius cubed. And in this particular case, I can't do that off the top of my head. You could work that out. Okay, it'd be whatever 4 to the 4th power is divided by 3 times pi. So anyway, that's how that would work if you're trying to find surface area or volume of a sphere. So again, if you don't know these formulas, I'd encourage you to write these down on a card or the front of a notebook somewhere. They just come up from time to time, and you need to know.